What happens when you eat a piece of your favorite chocolate or cake? It begins a process called a chemical reaction. So, what is a chemical reaction and how does it take place? Chemical reactions involve breaking of bonds and making new ones. It is often necessary to supply energy to keep the chemical reaction going. The energy supplied may be in the form of electricity, light, or heat. During a chemical reaction, a great variety of rearrangement of atoms takes place. There are several examples of chemical reactions taking place in our daily lives, like digestion of food, the curdling of milk, the ripening of fruits, etc. Respiration involves a reaction between oxygen from the air and various molecules present in the cells in our body. There is a vast variety of chemical reactions, and all of them involve breaking and making of bonds between atoms. Thus, chemical reactions always produce new substances. Consider the reaction between hydrogen and oxygen, which produces water vapor. It is represented as 2H2 gas plus O2 gas gives 2H2O gas. Here, the symbol G next to hydrogen, oxygen and water vapor shows that they are in the gaseous form. As you can see, both the number of hydrogen atoms as well as oxygen atoms on LHS are exactly balanced by those on RHS. The equation also balances their mass. 2H2, that is 4 hydrogen atoms, have a total mass of 4 AMU. O2 has a total mass of 32 AMU, and hence the total mass on LHS is 4 plus 32, which is equal to 36 AMU. The RHS has 2 molecules of water. The total mass is equal to 36 AMU. Thus, this equation balances the number of atoms as well as their mass. In this reaction, heat is liberated. Each mole of H2O formed liberates around 286 kilojoules of heat. Therefore, the actual heat released in this reaction is 572 kilojoules. Thus, we can see that a chemical equation conveys information such as the number of atoms, their corresponding masses, the physical state of the reactants and the products, and the energy change involved in it. To summarize, chemical reactions involve breaking of bonds and making new ones. The energy required for making and breaking bonds is supplied in the form of electricity, light, or heat. Chemical reactions always produce new substances. Chemical equations convey information such as the number of atoms, their corresponding masses, the physical state of the reactants and products, and the energy change involved in it.